Alright, I'm going to attempt to re-explain inverse trig functions. So what I've got on the screen right now is the sine cosine curves. And when we start talking about inverse trig, the thing I keep talking about is this horizontal line test. So if you go back to polynomials in first semester, when we talked about inverse functions, what we did was we checked to see if a function had an inverse. And we did that by drawing a horizontal line through our graph. And if the horizontal line passed through our graph exactly one time, then it was an inverse. But if it passed through our graph, one horizontal line passed through our graph more than once, then it was not an inverse. So here's what we have. Any horizontal line that I choose, it either strikes through it multiple times, basically infinitely many times, or if I go up further, I don't cross it at all. So really at no point do we have a horizontal line that touches exactly once. Okay, there we go. And that's true for both sine, cosine, and even tangent, which is down here. Okay, no matter where I draw my horizontal line, it's continuously hitting our trig function. So in order to find the inverse trig function, in our case, inverse trig is represented as, for sine, it's sine to the minus 1 of x. What we can do is we can restrict the domain of our graph. So, for instance, I'm going to take orange, and actually, no, let's do this. Let's take our highlighter, and let's just restrict our domain to negative pi over 2 to pi over 2. Now, we're going to go back and we're going to basically scribble out the rest of our sine function. Pretend like it's not even there. All we're focusing on is the domain of the sine function from negative pi over 2 to pi over 2. Now if we do that, we take our horizontal line, no matter where we draw our horizontal line, we're continuously only getting one intersection with our sine curve. So that's why when we find the sine inverse of a function, our answer is, here, let's do this. Our sine inverse is somewhere between negative pi over 2 to pi over 2. That's our new domain. So if I gave you a function that had sine inverse in it, your answer has to fall between negative pi over 2 and pi over 2. Somewhere in this domain right here. So let's do a real quick example. It's actually in our packet, back of our packet on 8.2. Very first problem. No, let's skip right ahead to question number 6. Sine inverse negative square root 2 over 2. Okay, we're looking at what angle gives us a sine ratio of the square root 2 over 2 negative. If you look at this on our unit circle, in general, square root 2 over 2 always goes with some form of pi over 4. So I'm just going to draw a really quick unit circle here. So again, sine inverse, we're only working in quadrants 1 and 4. Negative pi over 2, which is 0 to negative pi over 2, and up here, positive pi over 2. So in this problem specifically, we know that we are in this quadrant right down here. So our answer would be negative pi over 4. Had we been asked sine inverse of positive square root 2 over 2, then our answer has to be between 0 and pi over 2, because that's the only, of those two quadrants, that's the only quadrant signed positive. But because our sine inverse is being asked as a negative number, we need to narrow it down to 0 to negative pi over 2. And the only angle in that quadrant that's negative square root 2 over 2 is negative pi over 4. So our answer then becomes negative pi over 4. So you can pause the video here, write that answer down, because what I'm going to have to do is delete everything from here down in just a minute. So go ahead, write it down, pause it, whatever, and I'm going to delete everything here, hopefully. Alright, I'm actually going to stop this video right here so we can just talk about cosine in the next video.